Hi everybody, Mrs. Pesic here. We are looking at Summer Algebra 1 Review video number 7. The topics on this video are domain and range, graphing lines given slope-intercept form, and graphing lines that are given in standard form, and graphing horizontal and vertical lines. So let's take a look at this first example. Identify the domain and range for the given relation. Okay, in this first example, identify the domain and range for the given relation. So the given relation is these four ordered pairs. A relation is just a mapping between two sets of data, an input and an output. The domain is said to be the set of all input values, that would be your x values, and the range is going to be the set of all the output values, or the y values. So in this case, the domain is going to be 2, 6, 4, and 7. And we can put those in a set, 2, 4, 6, 7. All right, just put them in order there. And then the range is going to be your y coordinates. So that's -5, 3, -1, and -5 again. So I'm going to list those as -5, -1, and 3. So those are the range values. So for a relation to be a function, right? For a relation to be a function, every x value must go to a unique y value. In this case, is that what's going on? Well, 2 is going to -5. 2 is not going anywhere else. 6 is going to 3. 6 is not going anywhere else. 4 is going to -1. 4 is not going to any other number. 7 is going to -5. It's not going anywhere else. So the answer is yes, this is a function. Yes, a function. All right, let's take a look at example number 2. For example number 2, if I can get there, there it is. Identify the domain and range for the given relation. So same directions. The domain, again, is the set of all inputs. The range is the set of all outputs. So our domain is going to be 8, 4, 9, and 8 again. So I'm just going to write 8, 4, and 9. You don't have to put them in order. And the range is going to be your output value. So -1, 3, 6, -2. So let me list those. -1, 3, 6, -2. And the question is, determine whether it is a, so is the relation a function? Well, in this case, the relation is, let's see. Well, I've got 8 going to -1, but 8 is also going to -2. I cannot have one input value like 8 going to two different output values. So to answer this question, that's a big no. The relation is not a function because we have 8 going to -1, 8 is going to -1, and 8 is also going to -2. And that's no good. We cannot have that. So it is a relation, but it's not a function. Let's take a look at our next example. So here we're going to state the slope and the y-intercept of the line and then graph the line. So we have y equals 2/3 x plus 1, y-intercept, and the slope. Well, the slope is this number right here being multiplied by the x, so the slope is 2/3. My y-intercept is this number right here, which is 1. So I'm going to start by plotting that y-intercept right here on the y-axis at 1. And then my slope is 2/3, so I need to go up 2 and to the right 3, and I'm going to plot my next point right there. And I can repeat that process up 2 to the right 3, and I get my next point. Or I could go down 2 and to the left 3 and get my next point that way. So there's my line. All right, that's the graph of the line y equals 2/3 x plus 1. Let's take a look at example 4. State the slope and the y-intercept of this line and graph. In this case, the slope is -3. It's the number that's being multiplied by the x. And the y-intercept is -2. So we're going to graph this. We're going to plot -2 on the y-axis. And then now we're going to move with a slope of -3. You can think of that as -3 over a +1. So I can go down 3, down 1, 2, 3, and over to the right 1. And I get a point here, right? And I can do that again, down 3, to the right 1, get another point. Or I can think of this fraction here as a +3 over a -1. That would mean that I would go up 3 and to the left 1 and put a point. Let's do that one more time. Up 3 to the left 1 and put a point right there. And so my line is going to look like this. All right, notice that this line is falling, right? As we go from left to right, it is falling, and that makes sense because our slope is negative. All right, let's take a look at example 5. This time we're going to see a line that is not in slope-intercept form. It's in standard form, and you're going to state the x-intercept and the y-intercept and of the line, and then graph the line. So if it's 3x minus 2y, and we're trying to find the x-intercept and the y-intercept, to find the x-intercept, that's when you are going to plug in 0 for y. To find the x-intercept, you plug in 0 for y. So if I plug in 0 here, I would get 3x minus 2 times 0 equals 9, which means 3x equals 9, which means x is equal to 3. So my y-intercept, I'm sorry, my x-intercept is 3. To find my y-intercept, to do that, we are going to need to plug in 0 for x. So to find the y-intercept, we plug in 0 for x. So my original equation is 3x minus 2y equals 9, but I'm going to plug in 0 right here for x. And so I get 3 times 0 minus 2y equals 9. Negative 2y equals 9. So we end up dividing both sides by negative 2. And we get y equals negative 9/2 or negative 4.5. So I'm going to list this as negative 4.5 here. And so now I'm ready to graph. I'm going to plot my x-intercept. My x-intercept was 3, so I plot that on the x-axis right there at 3. And that corresponds to the order pair 3, 0, because 0 is y, 3 is x. And then the y-intercept is negative 4.5, so that's going to be right about here. All right, and then I just draw my line by connecting those 2 points with the straight line. All right, so that is the graph of 3x minus 2y equals 9. Let's do one more of those. State the x-intercept and y-intercept of the line, and then graph. It's 5x plus 2y equals negative 10. Again, if we plug in 0 for y, we can find the x-intercept. So I'm going to plug in 0 for y here. I get 5x plus 2 times 0 equals negative 10. If 5x equals negative 10, I get x equals negative 2 when I divide both sides by 5. So my x-intercept is, let me try that again, my x-intercept is negative 2. And now if I want to find the y-intercept, I'm going to plug in 0 for x. All right. And when I do that, plug in 0 for x. So I'm going to have 5 times 0 plus 2y equals negative 10, because my original equation was 5x plus 2y equals negative 10. And at this point, I am going to get 2y equals negative 10, so y equals negative 5. So if I plot these points, negative 2 on my x-axis would be right here, and negative 5 on my y-axis would be right here. And so I'm going to just draw my line through those 2 points. That's kind of a sad line. Let's try this again. And my line would look something like this. All right, let's take a look at example 7. All right, this time we're graphing a line x equals 4. There's no y in this, so it's just x equals 4. First of all, is the line horizontal or vertical? Well, if you forget, you can just plot some ordered pairs. All you know is that the x-coordinate has to be 4. So pick a few ordered pairs where the x is 4. The y could be anything. Could be 0, 1, 2, whatever you want it to be. So when I plot these points, 4, 0 is here, 4, 1 is here, 4, 2 is here, and it seems to me that's pretty clear that that's going to be a vertical line. So it's a vertical line. X equals a number is always vertical, but if you forget that, go ahead and plot some points and graph it. All right, so this is going to be a vertical line. Let's take a look at the next example. Example 8, graph the line y equals negative 2. If you forget whether that's going to be horizontal or vertical, plot some points. This time the y-coordinate has to be -2, so I can fill in -2's for the y's, fill in whatever I want, 0, 3, 6, whatever for the x's. So if I plot those points, I get 0, -2 is right here, 3, -2 is right here, 6, -2 is right here, and so we see that that's going to be a horizontal line. All right, so the answer here is horizontal, and this is our graph, nice horizontal line. Okay, so that brings up some practice problems for you. I'm going to let you just pause this video, try these on your own, and after you've tried them, then you can go on to see the solutions. All right, so pause it so that you can try these, and then I'll put the solutions up on the next page. All right, here we go with our solutions. So for the first one, number 1, there's the domain, there's the range, and the relation is a function because every x value goes to a unique y value. Here's the solution for the next one. Number 2, the slope would be -5/2, the y-intercept -2. The graph should look like that. All right, here's number 3. The x-intercept is -4, the y-intercept is 3, and the graph would look like this. And here's number 4, y = 5 would be a horizontal line, and it would look like that. Okay, hopefully you were successful at all of those problems. And if you're comfortable with all those, then go ahead and try the Summer Review Blackboard Quiz number 7. And if you have any questions, feel free to email us. Have a great day.